Start. One. Wow, that's totally not what I wanted. 1.8. And this is called inequalities. All right, 1.8 inequalities. Let's get at it. So let's start with something you might remember. Let's do example 16. This is number 16 in the book. 3x plus 11 less than 5. So talk to me. What do you want to do? What do you remember how to do?
Isn't like the sign just like basically an equal sign?
Yes, for now. And I'll tell you when it is, okay? So what do you think? What should we do? Just talk through it, guys. Yep, subtract 11. Oh, here you go. There's a blue for you. Those people who want me to use different colors. Coach, can you see it up there? Yeah. Barely. All right, so there's your answer to that. Now what do I do? Divide off the 3, so I'll just keep using those two different colors there. And x is? Well, it's -2. And it is less than. Now what I want to point out here is we're dividing by +3. We are not dividing by the -6. So if you multiply and divide, this is what I was alluding to a second ago. If you're multiplying or dividing by a negative, you got to turn that inequality around. Okay, so we are actually dividing by a +3 here, so it still stays in the same position. So x is less than -2.
What was that you just said?
When you multiply or divide by a negative, turn the direction of your inequality around. Okay, so now what I want you to do is I want you to graph this on a number line. Do you remember how to do that? How do we do that? Talk to me as you're writing.
You said.
Yep, it'll be an open circle because there's no equal sign.
When you multiply by a negative, turn the equality sign around? Or
Multiply or divide by a negative, you turn it around. And so now we're going to shade to the left because it is less than, right? What would this look like in interval notation? Interval notation is parentheses and brackets. So what do you think? Parentheses and a parentheses. You're not including the -2.
What you said that's called?
Interval notation. This is the part you guys did horribly on in that first quiz. And you've learned your lesson. That's why you're not asking what that is anymore. No, I'm totally calling you out. All right, you ready? Let's go on, shall we? So that was 16. Let's
know whether it's an open or closed.
if there's no equal sign under the inequality.
Wait, what?
That's okay.
So if there's an equal sign under the equality sign, it's a closed circle?
Right, because you're including that number. And of course, I'll add to that definition as we progress here. Okay. Let's go with number 20. Whoops. Let's do 28. 28 is 2 times 7x minus 3, less than or equal to 12x plus 16. All right, everybody solve that, please. I'm going to go ahead and solve this as you're finishing up, and then you can check to see if you did it right. And let's go ahead and move that to the left. You're going to want to try to keep your variables on the left side. It's just helpful at this point to do that. You do not have to, as long as you understand what you're doing. How do we know if it goes left or right? As long as x is on the left side, you can totally use the direction arrow of the inequality. If it's pointing to the left, then you shade left.
As long as X is on the right, or the left.
Left, yeah. Which we should probably do a different type of problem here. So let's go ahead and start the next one. Let's go with, all right, so this is number 38. And you have x minus 5 and x plus 4 greater than or equal to 0. Okay, so don't distribute here. This has already been simplified. If I were to write x minus 5 times x plus 4 is equal to 0, and I said, hey, what's your solution? What would you say the solution is?
No idea.
Sure you do, sure you do. If I said this, because you've been working on this in Algebra 1 and Algebra 2. And I say, what makes all that go to 0?
It's all times by 0. I don't know.
5 and negative 4 will make both of those go to 0, right?
Yeah.
Okay, that's what you're looking for. You're always looking for solutions. And what I need to explain to you at this point is those first two examples were examples from straight lines. And it was wanting to know, when you deal with inequalities, which part of the line is above the x-axis, greater than, and which part of the line was below the x-axis, less than. That's what you were doing on the last two problems. We're not asking you to graph those on an xy plane yet, but you will eventually. So what are we doing here? This is if you were to distribute like you were going to, you would have gotten a trinomial. Okay, so I'll go ahead and write that out for you, but don't do this. So if I distribute, I get x squared minus x plus, minus 20. So, minus 20, okay, equals 0. So an x squared, a quadratic is what that's called, is it's parabolic. It's a parabola. It's going to open up, and it's actually going to go through the x-axis at negative 4 and positive 5. That's what those numbers are telling you. Now, I don't know where the y-axis is at, but that's what that's telling you. Okay, now, so if we're looking at this sign right here, the inequality sign of greater than, it wants to know the part of the graph that is above the x-axis. That's what that is talking about. Where is the graph positive? Greater than 0 means positive. And also, where is it equal to 0? So the blue part there on the graph is really what you're going to be working on. You're trying to figure this out. Now, listen up. This is the beginning of us teaching you how to quickly understand and graph any equation. Okay? So we're not really graphing these yet, but we're trying to figure out a quick way of figuring out certain things. So let's go back to the problem. And we realize that we have 5 and negative 4 for numbers. So I'm going to show you a...
Negative 4. Negative 5 and 4.
What did I say?
Negative 4.
I said something wrong, didn't I? Okay, so 5 and negative 4 are numbers that are going to make this go bad. Well, that's the right thing. What makes that go to 0? 5. 5 minus 5 is 0, right?
I'm so confused.
Right here, right here. And that number, those are going to be what you substitute in for x to make it equal to 0. Because x plus 4, if x is negative 4, that'll make it 0, won't it?
Yeah.
Okay, so those are the numbers we're working with right now. Not that minus 5 there and not that plus 4. It's the values of x that make this go to 0. That's what we're looking for. Okay, so I'm going to show you how to make a chart to solve these things, and we're going to want to learn how to do this. You do not have to use the charts unless you have something really complex and you feel like, oh, maybe I should write this out. I would suggest you use the chart on tonight's homework to kind of get used to it. Okay? So here's what we're going to do. We're actually going to draw the number line first. So everybody draw a number line. And then we're going to put, let's see, negative 4 is smaller, so I'll put negative 4 here. And I'll put positive 4 there. Positive 5, geez. So always put your negatives on the left and your positives on the right. Sometimes you're going to have 3 and 4 numbers up here. Right now we just have the 2. Okay? All right, so the next part is you're going to put all the factored forms on the left side of your chart. You're going to make a gridded chart here. So do exactly what I do. I'm going to put x minus 5 there. And I'm going to put x plus 4 there. You don't have to have the parentheses around it.
Is she okay?
No, she's not feeling well. And then I'm going to draw, lines down from each of the numbers that are on my number line. And the last thing, on the lower left part of the chart, I'm going to write total. Okay, so our inequality is telling us we want positive values. That's what greater than means. Positive values. All we need to do is answer the question about whether it's positive or negative. You do not have to solve when I give you a number to substitute. Okay? So on our number line, if you remember our number lines on the first 2 examples, we shaded left and right depending on what it was saying. Well, those shades represent numbers that will work. Okay? So I want to know any number left of negative 4, because if it happens that I'm shading on those, I can choose any of those numbers, right? If I shade to the left of negative 4, I can choose any number. It should work. That's what you're checking. You're checking left of negative 4. You're checking between negative 4 and 5. And then you're going to check from 5 on to positive infinity. You can take any number that's in those ranges and plug them in for x. Watch how this works. So give me a number less than negative 4. It doesn't matter. You could say negative infinity because that would definitely be less than negative 4. Negative 5, that's totally fine. So now we substitute it in. So negative 5 minus 5, is that positive or negative? Negative 5 minus 5. Yeah, so again, I don't care what the actual solution is. It doesn't matter. What I want to know is what the value is. And you'll understand why here in a second. So now plug it into the next one. What's negative 5 plus 4? Negative. Be negative 1 if you want to know. And what are we doing in the problem? If we look, you can watch me guide you back up here. If we look at the original problem, what are we doing with both of those factors? You're multiplying. Okay, so what happens if I multiply the negative 10 times the negative 1? That's what you said those answers were. What do you get? You get a positive. Again, I don't care what the value is as far as the number. I need to know if it's positive or negative. That's all we care about. So anything left of negative 4, we're going to get a positive value if we substitute it in. Is that what we're looking for? Yeah, it's a greater than or equal to problem. So yes, we will actually shade, to to the left of negative 4. And we're also going to include negative 4 because there's an equal sign on it, right? Okay, good. So we'll move to the next one here. Pick a number, any number between negative 4 and 5. 3. Okay, that's a good one. So you substitute that in, and you guys fill out that column. Plug 3 in, and let's see if you can figure out your positive and negative out here. All right, so if we put 3 in, 3 minus 5 is negative. 3 plus 4 is positive. And if you multiply those, you get negative, and we don't want negative. Yes?
Where are you getting all those numbers from?
7. So we'll plug 7 in. What is 7 minus 5?
2.
2, which is positive, right?
Yeah.
So you're going to put positive there. Any number you pick bigger than 5, think about it. Think about it. I could pick 100 because that's in that range, isn't it?
Yep.
So 100 minus 5 is a bigger positive.
But it's still positive.
It's still positive. What about 1 billion? Okay, and that's something we should really think about. It's a useful tool to think about what infinity is. And if infinity is rough for you, pick 1 billion or 1 million. Because if I take 1 million minus 5, that's definitely positive. Okay? And 1 million plus 4, that's definitely positive. You can pick 6 if you want. That's bigger than 5. But many students really understand if I have a big positive number and I subtract 1 from it, it's obviously still positive, right? Okay, so we multiply those two together. Positive times positive is positive. So we are definitely shading that one because we wanted positive, and we are including 5 because it's also equal at that value, at 5. So negative infinity to negative 4, including negative 4. We also have 5, including 5, all the way to positive infinity. So we want to include both of these, right? Not just one of them?
Wait, why do we have a bracket?
Because it's included.
Why is that
It's
an
an
So
equal
a bracket means
How
including
did
the
you
number?
Yes.
determine that it's included?
Equal.
It has the equal sign. Look up here. Look, there's the bracket. And you have an equal sign. What makes it equal to 0?
I forgot that was.
Yeah. So this, you want to include both solutions, so that's why this needs to be a union.
I'm sorry, you lost me on why we put the bracket.
Because up at the top here, that equal sign,
Yeah.
because at negative 4 and 5, that makes it equal to 0.
Where did the infinity sign
I don't know.
come from? So like, I read.
Okay, next problem. Let's do something difficult. Example 64.
Was the answer a regular infinity?
Yes. All right. Rule number 1. Or I should say step number 1. Make sure this is that you have a 0 on one side. So what do you want to do? Move the 1 over. All right, so really the problem should look like this. Oh, not 1, sorry, 0. And rule 2, or the next step should be, if you have fractions with addition and subtraction, you need to combine them. So back to what we've been working on. You need a common denominator. And what is the common denominator? 3 minus x. And 1 is a really nice number to work with because we can do what? Change 1 into, 3 minus x over 3 minus x. So 3 plus x 3 minus x minus 3 minus x over 3 minus x. Okay? Now, everybody combine those, please. Let's see if you can do that right. So, we have 3 plus x, and you have a minus sign that needs to be distributed. So, that's minus 3 and a plus x all over 3 minus x. So, we have a 3 and a negative 3. So, did you all figure that that cancels out? And then you're left with 2x on the top and 3 minus x on the bottom. Okay. Now the special part. What numbers are special in this problem? What will make that fraction go to 0? That's next. If you have a 0 in your numerator, right, the top?
She's not in the bathroom.
Okay, she must have gone to the nurse. If you have a 0 in your numerator, doesn't that mean in the top? Doesn't that mean the whole thing is 0?
Yeah.
Okay, so what value of x makes the top 0?
Negative
2 times negative 2 is 0?
No.
No, what?
0. 2 times 0 is 0, isn't it?
Yes.
So if x is 0, that's one of our special numbers. Okay? Now, the bottom. What do you know about your denominators? What's a bad thing in your denominators? The denominator can't be 0. So what makes that go to 0? Positive 3. Okay, so your whole goal here is to identify all types of numbers, either good or bad, that are in your expressions. So those are the two numbers that we have here. Sometimes you're going to have 3 and 4 numbers, so don't get stuck on this. Okay, so I'm going to move this up just a little here. Now I'm going to draw a number line. And our numbers are 0 and 2, so let's put those in order. We're going to make our chart. And there is your, draw that there, and total. So here's our chart, and the exact same thing occurs. So what you need to remember from all this is it's got to be equal to 0 or have 0 on one side. And then you got to combine things. So you have this one expression and identify the numbers that either work or don't work. So both are necessary. So give me any number left of 0.
Negative 1.
Okay, negative 1. What's 2 times negative 1?
Negative 2.
It's a negative. And what is 3 minus a negative 1?
Negative 4.
No.
3 minus 2. Shoot.
Be positive.
Sorry, y'all.
Positive 4. Now, what are we doing with this? We are dividing, which is the exact same thing as multiplying. So what is a negative divided by a positive? A negative. Are we looking for negatives?
No.
No. All right, now let's pick a number between 0 and 2. 1. What is 2 times 1? Positive. And what is 3 minus 1? Positive. And what's a positive divided by a positive?
Positive.
Positive. Yay. Now that's what we're looking for. So we were looking for those. Now I'm not going to include those yet, so let's keep going. A number bigger than 2. 4. What's 2 times 4? Positive. And 3 minus 4?
Positive.
3 minus 4? Negative 1. And a positive divided by a negative is a negative. We don't want those. Now I'm going to come back to whether or not these are open dots or closed dots. So 0. If we plug 0 in for x, does it make it equal to 0?
Yeah.
Yes, because it's 0 in the numerator, right? So we're going to want to include, because there's an equal sign in the equation, we're going to include 0. All right, what about the 2. What in the world was I doing? That's supposed to be 3. Why didn't you guys say something?
I know, I was like, why you put 2?
What's where?
On the number line, it's
I just don't want it
53.
for the ride.
Sorry.
So
Oh my
confused.
goodness.
It doesn't change anything. You still plugged 4 in. Right? Right?
That wasn't it.
Right.
Okay.
Well,
We plugged 4 in, which is still bigger than 3. So,
I mean, why was it 3 and not 2 on
So the answer
Well,
is
on the-
comma 3.
What did you say?
you cannot have 3 in your denominator, or 0 in your denominator. So, yes, it's 0 to 3. You're not including 3, but you are including 0. All right, Google Classroom, check out your assignment.